Welcome back, RPS 7th grade scholars. Today we're going to work on word problems, practical situations for surface area and volume of rectangular prisms and cylinders. Our objective of the day, I will be able to solve problems including practical problems involving the volume and surface area of rectangular prisms and cylinders. You are going to need your formula sheet to help us, and you will need to have your Desmos app open or your scientific calculator, some pencils and paper, your notebook to jot down some notes as needed. So we're going to listen to this first video. Again, stop the video when you need to, jot down some notes, and it's just going to give you some helpful hints and helpful information on how to solve word problems using volume and surface area of the rectangular prism and cylinders.
In this video, we're going to discuss how to solve volume and surface area word problems. So we have 5 steps we need to follow. Number 1, determine what 3D object you have and draw a picture. This will either be a cylinder or a rectangular prism. Step 2, determine if you need to find volume, and that means if you're going to be filling up that 3-dimensional figure, or surface area, and that will happen anytime you need to cover a 3-dimensional figure. Step 3 is to select and write the formula that you will need to solve the problem. Be sure to determine if you need the whole formula or only part of it. Sometimes we'll have to modify our formulas in order to fit the information that we're trying to find. Step 4 is to set up your equation, and step 5 is to solve. Be sure to include the proper units in your answer. So example 1A. A packaging company needs to know how much cardboard will be required to make boxes 18 inches long, 12 inches wide, and 10 inches high. How much cardboard will be needed for each box? So the first thing I'm going to do is I'm going to sketch a quick picture of a rectangular prism. A box is a rectangular prism shape. So I have a box that is 18 inches long, 12 inches wide, and 10 inches high. So 10 inches high, 18 inches long, and 12 inches wide or deep. There's my rectangular prism. And again, the sides are labeled. How much cardboard will be needed for each box? So think about cardboard in a box. It's actually covering the box. I'm not talking about filling up a box. I'm talking about covering it or creating the surface of that box. So this is going to be a surface area question. So it's helpful to have your handy-dandy formula sheet. It's the first page in your notebook, so that's where you can find this information. So surface area for a rectangular prism is equal to 2 times the length times the width, plus 2 times the length times the height, plus 2 times the width times the height. And then I can plug in my numbers. So my surface area is going to be 2, length is 18, and the width is 12. Plus 2 times the length is 18, and the height is 10, plus 2 times the width is 12, and the height is 10. So I'm going to do this in 3 separate pieces because they're separated by plus signs. So 2 times 18 times 12 gives me 434, plus 2 times 18 times 10 gives me 360, plus 2 times 12 times 10 gives me 240. So I did each one of these chunks separately. This one, and then this one, and then this one. Then I can add all those numbers together, and I end up with 1,034 inches, and its surface area, so inches squared. Example 1B. Now suppose the boxes did not need lids, so we're trying to get rid of the lid. How much cardboard would be needed for each box? So my picture looks pretty much the same. I have a rectangular prism, 10 by 18 by 12. But now I'm not going to have a lid. So I have to think about what are the dimensions of this lid. Well, the lid is going to be an 18 by 12. So it's 18 inches across and 12 inches deep. So I'm going to have to modify my formula a little bit. So I start with my original length times width plus 2 times length times height plus 2 times width times height. But I'm not needing this lid part anymore. So that is a length times a width dimension. So instead of having 2 length times widths, one for the bottom and one for the top, I now only have 1 length and width because there's no top. So I have to delete out that 2. So then I can go through and I can plug in my numbers again. I have 18 and 12 plus 2 times 18 times 10 plus 2 times 12 times 10. So again, modifying that formula to fit my needs. 18 times 12 gives me 216. Multiply those 3 numbers, I get 360. And multiply those 3 numbers, I get 240. If I find the sum of 216 plus 360 plus 240, I get 816. This is still a surface area question, so it's going to be measured in inches squared. Example number 2. A cylindrical water tank has a diameter of 5.3 meters and a height of 9 meters. What is the maximum volume that the water tank can hold? So this one tells me it's a cylinder. So I'm going to draw a cylinder that holds some water. It has a diameter of 5.3 meters and a height of 9. So I'm asked to find the volume. So volume for a cylinder is pi r squared h. I'm given the diameter here. I have a diameter of 5.3. So I need my radius. I'm going to take my 5.3 and divide that by 2. So my radius is 2.65. Then I can plug in. Volume equals 3.14. The radius is 2.65. And the height is 9. And then I want to make sure I remember to square the radius. So I'm going to square the radius first. And that gives me 3.14 times 7.0225 times 9. And then I'm going to multiply those 3 numbers together. And I get a volume of 198.46. And this is volume, so it's going to be meters cubed. And of course, I rounded that. There's a lot more decimals that come after here. I rounded it to the hundredths place. All right, example number 3. The cargo carrying part of Billy's truck has a length of 8.3 meters, a width of 3 meters, and a height of 4.2 meters. What is the maximum amount of sand that Billy's truck can carry? So if I think about a truck, and I think about the bed of a pickup truck, that's pretty close to a rectangular prism. Also, I'm cued in here because it says length, width, and height. So when I'm doing rectangular prisms, length, width, and height are the measurements that I'm given. So this particular truck has a length of 8.3 meters, a height of 4.2 meters, and a width of 3 meters. And I'm thinking about putting sand inside the bed of this truck, so I'm going to be filling up the truck. And when I fill something up, I'm looking for volume. This one doesn't tell me exactly which one I need to find. So I have to decide filling up means volume. So I'm going to use volume equals length times width times height. So my length is 8.3, my width is 3, and my height is 4.2. I'm going to multiply all of those numbers together, 8.3 times 3 times 4.2, and I get 104.58 meters cubed. All right, example 4. The tube for a certain water slide is 40 yards long and has a radius of 2 yards. How much plastic is needed to construct a tube? Hint, does the tube have ends? So I'm thinking about a water slide, and it's a tube. A tube is a cylinder. So I have this tube that forms a water slide here, and I kind of drew it at an angle. You think about coming in at the top and sliding down the tube. So I know that this tube is 40 yards long, and it has a radius of 2 yards. So from here to here is 2. So if I think about a slide, a tube, if you've ever been to water country or any of the water parks in Virginia, a tube cannot have ends on it. How unfortunate would it be if you tried to go down a water slide and you couldn't get inside the tube because there was a lid? And even more unfortunate if you got down to the bottom and there was an end cap. That wouldn't be a very fun slide. So we need to think about how we can modify our formula in order to meet the needs that for this problem that it does not have ends. So there are no ends. I'm looking for how much plastic is needed to make this tube. So the plastic is the covering for the tube. We're not talking about filling this up with water. We're talking about constructing on the outside. So this is going to be a surface area question. Surface area for a cylinder is 2 pi r squared plus 2 pi r h. And then I've got to figure out, since this doesn't have ends, part of this formula is going to go away. And if you look closely, this first part of the formula has the area of a circle embedded in it right here. That's the formula for the area of a circle. The two ends are my two circles, one for the top and one for the bottom. Since I don't have ends, this is the part of the formula that I can get rid of. So really, I'm only concerned with the second part. I'm looking for the covering of this tube. So my surface area is going to be 2 times 3.14 times a radius of 2 times a height of 40. So 2 times 3.14 times 2 times 40. Try that one more time. 2 times 3.14 times 2 times 40 is going to give me 502.4 yards, and its surface area, so it's squared.
Problems that we're going to be working on there is coming from our learning packet, and it's going to be the first few problems. I went ahead and put these on our PowerPoint so that we can see them together in case you do not have access to the learning packet, but it is located in your learning packet on page 23, and we're going to be doing numbers 1, 2, 3, and 4, page 23 and 24. That's where we're going to look, and that is linked in your learning plan for today. So you have done a lot of practice looking at her actually go through each step, making sure you can discern which formula to use, what part, whether it's volume, whether it's surface area. So think about that. Take about 10 minutes or so, or however long you need. Write out the formula, read the questions carefully, draw out the pictures. This is your time to do some practice problems, and then we're going to come back and look at these answers. So again, take your time, pause the video, get your calculator out, make sure you draw out your write out your formula, put it in your calculator twice, and then once you're done, come back and let's talk about our solutions. All right, so here, check your answers. Let's see. And for the questions that you see me having a little picture, it was because it wasn't a picture drawn. So I had to actually read through the problem and look at it just to make sure that I knew exactly what it was asking for. So I drew out the picture and I put whether it was giving me diameter. And if I saw that it was giving me diameter, I wrote the radius and then completed the formula for what it was asking me from that point on. Each problem is written out with the formula. Each problem is written out with the variables being replaced by its names or by its length or width or height or radius for that fact. So you want to make sure that you're clarify that you are writing the information out and that you're actually placing it in your calculator twice. So great job. So your independent practice for today is again from your learning package. Again, we're going to be looking at page 24 and 25, and you will be doing numbers 5 through 10. So 5, 6, 7, 8, 9, and 10. And again, your helpful hints: draw a picture when you need to, determine your keywords, use your formula sheet. That is always a plus. Always put your formula at the top of your paper. And always, always write it out, replace with the correct variables, and then use your Desmos online calculator or your scientific calculator and break it out into your parts if you need to. For that part, you're going to do that independently, and we're going to give you the answers on tomorrow. On the next day, you will get the answers to these problems. So you can pause the video and get that done now, or you can come back to it in a very few minutes. So your objective of the day, I will be able to solve problems, including practical problems involving the volume and surface area of rectangular prisms and cylinders. Think you've done an awesome job. Of course, after you have finished completing your 5 through 10 problems on your learning packet, if time allots, please take about 10 to 15 minutes to work in your Dreambox account. I thank you, and I will see you soon.